Hi everyone, what we're going to look at today, we're looking at illuminance. So in this case, light levels. So light levels directly below light, and also we're going to go a little bit further and look at what happens to light levels when we move across from its direct path underneath and see how the levels of light deteriorate as we move further away from the lamp. So to start, we're looking at basic equations. So the basic equations we're looking at for light is E equals I over D squared. So E is your illuminance, I is your candela, which is what's given to us, and D at the bottom is distance. So it's nice and straightforward, this one. So all we do here is 2,500 candelas divided by your distance, which is 5 squared. So 2,500 divided by 5 squared. Basic maths, 2,500 divided by 25. So we'll do it on a calculator just in case anyone's unsure. So again, I always use a fraction symbol no matter what I'm doing when we're doing division, so we can't go wrong. So 2,500 divided by 25. I'll do that underneath 25. And it gives 100, so 100. Unit of measurement for illuminance. Give you a second to think if you can remember what that would be. So look at lux. 100 LUX. So 100 lux. Now that's really straightforward, and you get a couple of marks in the exam just for doing that. But what really pushes you on to the next level is being able to do it when you're moving across. Not directly below, but across in an angle. So another example that we've got is calculate the illuminance at point B. Point B being all the way over here. So instead of being straight down from the lamp, it's looking across. You can see it's further, isn't it? 4 meters down, it's further across. And that's basic Pythagoras again. So when we consider this, we'll look at Pythagoras and the simple equation behind that. So Pythagoras is a squared equals b squared plus c squared. So all we do there, we look at this, and we're looking at this long side there. So we're looking at the hypotenuse. This is the longest side. So a squared equals square root of b squared plus c squared. So in our case, all we're doing there is 4 squared plus 3 squared, and we're going to square root your answer. So nice straightforward. So this is a basic 3, 4, 5 model, so rather than doing this on calculator, tell you that the longest side can be 5, but we will do it. So square root of 4 squared plus 3 squared, square rooted, you can see it gives us 5. And the other two measured in meters, so this one is also measured in meters, so 5 meters. Got 5 meters across. What we need to do now is work out the cosine of the angle. So we've got an angle there, the cosine of the angle. So remember back to your days at school when we learned about cos. So cos is your adjacent divided by your hypotenuse. So our adjacent is 4 meters. Our hypotenuse is this over here, which I'll label up as 5 meters. So nice straightforward, 4 divided by 5. And that there gives me my cosine angle. So 4 divided by 5 on a calculator, I'm sure you don't need to, but 4 over 5 is 0.8. So 0.8. So the next stage we need to do from that, guys, we need to put this all into an equation. So going back to my equation from the first question, E equals I over D squared. This is slightly different, it's got one more step involved in it. And what it's got involved in it is the angle on top. So E equals I times by cosine of my angle over D squared. And when we're doing this, remember that the distance is not the 4 meters down. It's a distance from the light to the source. So it's the distance on the hypotenuse, which is 5 meters. So we'll do this question. So the candelas, which are going on top, we've got 1,000 candelas. So 1,000 times by the cosine of the angle, which we've worked out on the left hand side, is 0.8. Okay? So 1,000 times 0.8 divide by distance squared. Again, I just told you the distance, not the 4 metres down, it's the 5 metres across, so it's 5 squared. So we can do that on the calculator over here, guys. Fraction symbol again. 1,000 times 0.8. Go to the bottom of the equation. 5 squared on the bottom. And it gives me a lux of 32. 32 LUX. Now that's not very many at all. It's quite low, to be fair. But again, it all depends on the brightness of the lamp. So the lamp might not be that bright to start with. So what I would do now to compare that, I would look at what the light would be directly below, which is straightforward. So you've got 1,000 candelas 4 metres down, so I could do that. So I could do 1,000 over 4 squared. So over there, 1,000 over 4 squared, and it gives me 62.5. So you can see straight away that it wasn't that bright to start with. So 62.5 lux straight below the lamp, 32 lux across. And this is quite relevant. So if you consider when you're in a classroom environment, if you look up to the ceiling and see that there's light fitting in above somebody's desk, and the person sat next to them may have a light fitting above them. If you're sat to the side, you might not have a light directly above you. It comes on the angle across, which is what we're looking at. So directly underneath that lamp, the person sat there is going to have a brighter desk space than you are to the side, which is why we don't have lights just central in the room, in a room that depends quite a lot on the lamps. We've got quite a few lights dotted about. So in an average classroom, you could probably have 12 lights. If you go into like a commercial style kitchen these days, you can have lots of lights spread out across the room. Do you still get any dark patches really? Which is what we're trying to avoid, because dark patches create shadows, and that's how somebody could get injured or not be able to see what they're doing properly. So hopefully that helped you a little bit on lighting, guys. Thank you.